Okay, ladies, we're going to do activity 12, determination of Faraday's constant and Avogadro's constant. So I'm going to try and do the experiment for you, and then you'll grab the results. So it just wants us to clean the copper electrode, and that's just to get the oxide layer off, the corrosion. The prac then asks me to label the cathode with a C, just so that we know that it's a C. So there's your nickel, and that'll make the anode. So, all right, we have to weigh the copper strip first. So I'm just going to grab a watch glass, and I'll tear that on the scale. Okay, so I'll just grab my that's the weight of the cathode, the copper strip. Now what it's asking me to do is to place the copper electrode and the nickel electrode opposite each other in a 100ml beaker. So I've got my 100ml beaker here. And I don't want the two electrodes to touch. So the easiest way is to grab it, and because these metals are pretty malleable, I'm just going to fold them over the lip of the beaker. Alright, so you can see I've got my copper and my nickel in there, they're not touching. Okay, I'm going to bring it over, and hopefully I'll be able to set you up so that you can see it. Okay, I'm going to turn the beaker around, but I just wanted to show you, yes, I am labelling the equipment, but it's probably going to be easier to see it from this view. Okay, and then I'll give you a close-up view once I've set it all up. So the next part of the prac, it asked me to pour 60 mils of your nickel sulfate. So I've got gloves on because it's an irritant. Alright. So this is Faraday's in electroplating, so I do need to run a current through the solution if there's going to be any plating. Alrighties, so what I need to do, I don't want to actually connect it up to the electrolytic cell yet. I just want to make sure we're all set up properly, and then it's actually asked to get a current of 1. So once I get that going, I'll show you the ammeter so I can prove that I got a 1 amps running through it. We don't have an adjustable resistor, so I'm just going to change the volts on the power pack if need be. I have to leave it run for 10 minutes and then turn off the power. I have to record the current that passed through the cell, so hopefully that doesn't vary too much, and then I have to wash the copper electrode in water and then acetone. I'll explain why I'm doing that when I do that, and then I have to reweigh it because we need to calculate the mass. Remember, charge is proportional to mass. Alrighties, let's go. So we'll connect this one up to there, and my cathode needs to be connected up to the positive on the ammeter. Now I am going to put it on the, I'm going to put it on the 1 and hope that it's not more than 1. Usually, actually I'll put it on the larger one first. Okay, I've connected that up. I don't want them touching. Are they touching? Okay, better. All right, so get it on. It's exactly on 1 amp, pretty much. If I go, yeah. So I'm going to have to set it on that. I'll show you the amps that are running through after I turn the stopwatch on. Not quite. Oh, I reckon we do nearly have 1 amp. So I've got it on the 5 amps. So we read the top scale. And as you can see there, it's sitting on 1. So actually I had it on 6 volts to get that one, but the volts doesn't matter in this prac. What we need to keep an eye on is the current. And I want to show you what's going on in the beaker if we can. Are they touching? So you can see there's a fair reaction going on there. There's a lot of gas being produced. It is an aqueous solution that I'm using. And at this point, 1 minute, 14 seconds. Chemical series, and see if you can figure out what half equations are going on. So we've got nickel in there, nickel solid, and nickel aqueous. We also have copper solid, and we have our 2 water half equations. Okay, so remember that Q equals I times T. So I've got to turn this off on exactly 10 minutes. Well, that's what the instructions were. So there's 30 seconds to go. Okay, and I've just turned it off. Alrighties. The next part of the experiment says that to record the current that went through, you had that current. Alright, so it was 1. And carefully remove the cathode from the cell and wash it by first dipping it into a beaker of half-filled water and then in acetone. So I need to remove the cathode. I'll show you what it looks like before I... Okay, so we can obviously say something's going on there. It said to put it in the water. So that's going to clean it. I didn't want to add the acetone until I was ready, girls. Sorry, because it is flammable. And then I need to add it to the acetone, and that's actually going to help to dry it. Because it says it needs to air dry. So I'm just going to leave it there to air dry, and then we'll weigh it. I just thought I'd actually show you what the nickel looks like. So you can't really see any difference on the nickel. Try and get some more light in there. Oh yeah, there you go. Just a little bit of a difference. Okay, so that's dried now. See, it's got sort of a green tinge on it. All right, gonna weigh it. I didn't actually note down the weight beforehand, so hopefully you can see that, girls.